Hello guys, my name is Jessie Garcia and today we will be working on balancing equations. These are the problems that we're going to be looking at. If you want to, you could pause the video so you could take a look at the problems. We're going to go ahead and get started now. Okay, so the first problem we're going to be looking at is the reaction of xenon and fluorine, which gives the molecule of xenon hexafluoride. We're going to be looking at the left side to start with. There isn't any coefficient in the xenon, so that means there's only one. Fluorine, there's two since it's diatomic. In the other side, same, no coefficient, one xenon and 6 fluorines since it has the subscript of 6 right underneath there. So that's a hint. Moving on, we're going to start to realize what we have to put in these blank lines to make this equation balanced. We're going to start with xenon, so we have already a 1 and 1 in both sides, so we could just go ahead and write the ones. Good. And then we're going to look at the fluorines. There's 2 there. How many do we need to have 6? So we need 3, so 2 times 3 is 6. 6 on the left side, if we times that, 6, and then 6 on the other side, which it's pretty balanced, so we put the 3 there, and that is it. That equation is balanced. Okay, so I'm just gonna go ahead and highlight this so you guys can see it better. 2 and 3 that we multiply to get that 6 and get the fluorine balance. There you go, so you guys could see it better, nice and neat. Now we can move along to our next problem, which is a little bit more complex. Okay, so in this equation we have iron 3 chloride and sodium hydroxide in the left side. We're going to start counting our ions. First we have 1 iron, 3 chlorides because of the subscript in front of chloride ion, 1 sodium, 1 hydrogen, and 1 oxygen. The other side, same, 1 iron, 1 chloride, 1 sodium. We have 3 hydrogens and 3 oxygens in this side because due to the subscript which encloses that hydroxide molecule right there, so it counts for the oxygen and the hydrogen. Very good. Now we're going to start balancing these. That's a hint that we should start there. So iron is balanced already, but chloride isn't. These are the things that we need to follow to balance this equation. So for iron we don't have to do much, looks pretty balanced, but chloride isn't. So what do we have to put in the chloride? A 3. We have to put a 3 in the a 3 in front of the chlorine, 3 in front of the sodium. So means we have to put a 3 in front of this whole molecule. That makes it have 3 hydrogens and 3 oxygens as well, because we put that 3 coefficient there. Iron, it's pretty balanced in both sides, so we just go ahead and put a 1 there. Iron, it's balanced, 3 chlorines, 3 sodiums, 3 oxygens, 3 hydrogens, 1 iron, 3 chlorines, 3 sodiums, 3 hydrogens, and 3 oxygens, and that is it. This equation is balanced. I'm just gonna go ahead and highlight these so you guys can see the coefficients better. These are the final coefficients for our balanced chemical equation. Now we can move on to our next equation, which has calcium chloride and silver nitrate in one side. I want to take note of the nitrate, which is a polyatomic ion. We can, if you want to, it makes it easier for you, highlight that polyatomic ion so you don't break it apart. It's NO3 in one side and NO3 in the other side, so we don't have to break it apart. Let's not make life harder for us. There's a 2 in front of the nitrates. That subscript is very important. It goes for the calcium and the nitrates as well. If you want to, you could circle it as well so you don't forget about it. Right there. So we have that noted down there, and we can go ahead and start balancing, not balancing, counting down when we have an ions in there. This side there's 1 calcium, 1 chlorine, and 1 nitrate. This side we have 1 calcium as well, 1 chlorine, 1 silver, and 2 nitrate ions. So let's go ahead and start with the left side. Calcium and calcium is balanced. We need 2 chlorines to make this balance. We'll put a 2 here. Chlorine is balanced, but now we have 2 silver in this side, which means we have to put a 2 in the other side to make it balanced. So go ahead and put a 2 here. So 2 silvers in both sides. Nice. Balance. So I know 3. I'm pointing down here. There's going to be 2 on the left side. Looks like everything is balanced. 2, 2, 2, and 2. Let's put a 1 here on the calcium and a 1 here on the calcium nitrate, just so we don't think it's a 0 there. It's better just to put the 1 so we can know it's nice and balanced. That's going to be our subscripts, not subscripts, our coefficients in front of each compound. So 1, 2, 2, 1, it's going to be the coefficients for our final equation. This equation is now balanced, and that's it. I'm going to go ahead and highlight that so you guys can see it better as we did before. Set in stone, these are the coefficients for the balance equation.
Hey guys, this is Sabeda. I will be finishing the second part of this project. Now, as you can see, we have a chemical equation dealing with silver and also hydrogen sulfide. Now, as you can see, it's unbalanced. We go ahead and line up all the elements that we have, and we take a look at the subscript at the bottom, and it lets us know how many of the actual ions that we have. As you can see, we have silver, sulfur, hydrogen. So we have 1, 1, 2, and on the other side we have 2, 1, 2. As you can see, the silver doesn't match, so we go ahead and cross that out, and the coefficient is easy, it's 2. Now the sulfur, it is 1, and hydrogen is 2. So we have to keep in mind that we never change the actual subscripts, we only change the coefficient. Now, when looking at the subscript, remember the subscript always deals with the ion that is closest to it. You have to keep in mind if there are any parentheses or if we have any additional coefficients that are either given to us or anything that's outside of the parentheses that we have to multiply. So remember that when we're looking at these equations, we always want to keep in mind the seesaw effect. Everything must balance. If not, you're going to have something like this picture right here. Unbalanced equation. All right, so feel free to pause the video at any point if you want to give some of these chemical equations a try. As you see here, we have potassium hydroxide, carbon dioxide, potassium carbonate, and the famous H2O, water. So as you see here, I always like to underline my subscripts just so that I know the subscript that is attached to which element. Now, I always like to leave hydrogen and oxygen for last because hydrogen and oxygen tend to pair off usually with more than one element at a time. So sometimes they do not form polyatomic ions, so we cannot go ahead and treat them as one entity. So I like to go ahead and always leave them for last because sometimes if you deal with oxygen and hydrogen first, they tend to complicate your numbers, and sometimes you just lose track of which and where the number actually belongs here. So remember, we never change our subscripts. We're only dealing with coefficients here. So now that we have everything in order,
just gonna start counting.
To write down
we have 1 potassium,
the amount
one carbon,
of each element. So we
and
have 1
1
potassium,
hydrogen.
but how many oxygens do we have?
1 hydrogen.
I do see
now,
that
with oxygen, how much do you think
potassium
we have a
hydroxide
2
has 1,
and we have
carbon dioxide has 2. So it's 3 oxygens.
We actually have
now here we have 2 potassium,
oxygens,
1 carbon, 2 hydrogen, and how many oxygens do we have?
1 carbon.
Well, I see that H2O has 1, and I see that the potassium carbonate has 3
here.
So right now I know that I see that there are 4 oxygens. Now remember, we never change the actual subscripts, and we have to understand that the coefficient goes ahead and multiplies straight through.
Now we're going to go ahead and try to balance.
I have to see if everything lines up, and I see that my potassium is not lining up. So I change the coefficient
to 2, but that changes
now that
everything.
I'm changing the coefficient,
so now
I see that changes everything. And so now it changes that I have now 2 hydrogen instead of 1.
That's going to
but does it change my oxygen?
So
absolutely.
We have 2
now instead of having 3, I have
so we have
4.
to change that everything to
now,
4.
So if you always want to see it's going a little too fast, just take a pause.
That we have 2,
but as you
1,
can see,
2,
everything
4.
is now matching up. 2, 1,
so
2, 4.
remember, don't get confused when you see that oxygen is actually
you're always writing in your coefficients and you're multiplying it. If you don't see a coefficient like you see here on the carbon dioxide for carbon, let's say, so we can assume that the subscript for carbon is 1 because there isn't even a number there, but it's there. So it's 1 times 1, which is 1 carbon. 1 times 2, which is 2 oxygen. The equation, just take it slow. Always keep that in mind here when we saw that on the left side, which is the product part. We do see that oxygen, and remember, always leave your 2, and then we see that oxygen has nothing near it, which we can assume that when you don't see a subscript, we assume that it's number 1, always. Just like when you see a coefficient and there's nothing there, we assume that it's 1.
Are we multiplying
so just try to take your time and go ahead and write all your elements out.
We are.
Make sure that you go ahead and line them up so that they match left to right, product to reactant. All right, guys, bonus time. Now this particular problem, I do want you to pause and try to give it a go. I'm going to show you a neat trick here. Now, as you can see, we have aluminum and oxygen. We have 1 aluminum and 2 oxygen. Now, on the other side, we actually have 2 aluminum and 3 oxygens. Now, when balancing, this is easy. I see that 1 times 2 obviously is 2, so the coefficient is 2. But now I see that I have 2 oxygens on one side and 3 on the next. How am I going to multiply, or what can I multiply number 2 to get 3? Well, in this case, we would just divide 3 divided by 2. And that's going to give me 1.5. That is my coefficient. Now, I would go ahead and add the coefficient to the oxygen, because 1.5 times 2, remember the coefficient times the subscript, it's going to give me 3. Now everything's balanced, right? So we're done. No. We have to go ahead because we do not want integers or any numbers with decimals. We want to deal with whole numbers when we're dealing with chemical equations. Now, as you can see, I added that 1 on my product side. Usually if we don't see a number, we automatically assume that it's 1, but I always like to add it visually so that I know exactly what I'm dealing with. Now, because we want everything to be a whole number, we're going to multiply it by 2. Now, it's only multiplying the coefficient. So here, 2 times 2, which is 4 aluminum. Now, 2 times 1.5 is going to give me 3 as a coefficient. So it's 3 times 2 of the subscript. It's going to give me 6 oxygens. And now the product side, 1 times 2 is obviously 2. So it's going to go ahead and balance everything. So now I have to change everything. How many aluminums? How many oxygens do I have? I see that my aluminum changes to 4. Oh, but I forgot my subscript. Never forget your subscript. So 2 times 2, obviously it's going to give me 4. And here I have 3 times 2 for my oxygen. So this turns into 6, and here 3 times 2 is 6. Remember, we always want to see if there's parentheses that are separating the actual elements. I don't have a parentheses here, so obviously the coefficient of number 2 goes straight into the actual element of the aluminum oxide. So it's 2 times 2 for the aluminum, and then 2 times 3 for the oxygen. All right, guys, last problem. So as you can see here, we have aluminum, sulfuric acid, aluminum sulfate, and hydrogen. Can you spot the difference? From the product side and the reactant side, there's a big difference happening. As you can see, we do have a polyatomic ion, but one is separated actually by parentheses and one isn't. So do we consider it a separate entity, as one entity, or do we take each element as it is? In this case, we're going to separate each element as it is. So it's going to be aluminum, hydrogen, sulfur, and oxygen. Now, we're going to go ahead and look at the subscripts, of course. I see that I have 1 aluminum. I have here, now how many sulfurs do I have? Do I have 4 or do I have 1? I have 1. And then hydrogen here, I have 2. And I have 4 oxygens. Again, I have 2 aluminums. How many sulfurs do I have here? Well, there's a subscript of 3. So is it 3 times 4 or 3 times 1? It's 3 times 1. That 4 does not belong to the sulfur. It belongs with the oxygen. We have 2 hydrogen and we have 12 oxygens. Remember, oxygen usually tends to be very complicated, so we leave it for the last on the list. I have 2 aluminums. Now, my sulfur, how can I get 1 times something to 3? Obviously, it's 3. So we change that, but now that changes everything there. So now my hydrogen is 6, and my oxygen becomes a 12. Is this balanced? No. My hydrogen is still not balanced. Well, what can I multiply by 2 to get 6? 3. So 3 times 2 is 6. And now everything is balanced. 2, 3, 6, 12. Remember, don't become intimidated if you see large numbers, and usually leave hydrogen and oxygen for last. And remember, if we see parentheses on the product side or on the reactant side but not on the next side, that means that we don't have to consider that particular polyatomic ion as one entity. We consider it as separate elements. So let's summarize what we've learned. We've learned that what we have on the product side, we must have on the reactant side. We never change the subscripts when balancing, just the coefficients. We always leave hydrogen and oxygen for last. And if you do see a polyatomic ion on the reactant side or on the product side, but you don't see it vice versa, then it's not one entity. But if you do see that it's separated by parentheses on the product side and on the reactant side, then yes, let's consider it as one entity. And when your balancing is complete and you're still left with decimals, just multiply all the coefficients by 2. And remember, as I said, when you're dealing with multiplying your subscripts, remember, if it's separated by a parentheses, like we saw with the sulfate, we saw that oxygen had a subscript of 3, but sulfate only had a subscript of, actually, you didn't even see a subscript. So you want to be careful and you want to make sure that you're multiplying the correct coefficient and subscript. I really hope that this video assisted you guys in any way, please leave a comment if you have any questions or concerns, or if you have any additional chemical balancing questions. We'll be more than happy to help you.